Walk into any marine mechanics shop and ask what engine they run on their personal boat. You'll hear the same answer over and over, something from the late 90s or early 2000s. Not brand new, not cutting edge. A 25-year-old diesel or 4-stroke outboard that's been running since the Clinton administration. These are the people who fix boats for a living. They see every engine failure, every design flaw, every warranty nightmare that comes through the door, and when they spend their own money, they choose engines that are old enough to rent a car. There's a reason for that. A specific window in marine engine history where reliability, simplicity, and serviceability came together perfectly. Before emissions regulations complicated everything. After the major reliability problems got sorted out, the sweet spot that nobody talks about. Today, we're diving into why mechanics choose 25-year-old engines, which specific models they trust, and what this tells us about what really matters in marine propulsion. Let's start the clock. First, understand what happened in the late 90s. The late 1990s represented a unique moment in marine engine development. Manufacturers had spent the previous 2 decades refining their designs. The major failure modes were understood and solved. Materials science had advanced enough to provide genuine corrosion resistance. Manufacturing quality had improved dramatically from the 1970s and 80s, but the complexity that defines modern engines had not yet arrived. Electronic fuel injection was just becoming standard, simple enough to be reliable yet not sophisticated enough to create new failure points. Engine management systems monitored basic parameters without the dozens of sensors that modern engines require. Emissions regulations existed, yet they were mild enough that manufacturers could meet them without exotic aftertreatment systems. 4-stroke outboards were replacing 2 strokes, bringing automotive-level durability to applications that previously wore out engines quickly. Marine diesels were adopting indirect injection systems that improved efficiency without the high-pressure common rail complexity that would come later. Everything was getting better while nothing had gotten overcomplicated yet. This created engines that combined proven mechanical designs with just enough electronic sophistication to improve performance. The reliability of older mechanical systems with the benefits of basic computerization. That combination turned out to be the sweet spot. Now let's talk about what mechanics actually choose. Walk through a marina where mechanics keep their personal boats and you'll see specific engines appearing repeatedly. The Yamaha F115 4-stroke from 1999 onward. The Mercury Optimax 2-stroke from 1996 through the early 2000s. Honda BF75 and BF90 models from the mid-90s. Honda BF115 and BF130 from 1998. Yanmar and Perkins diesels from that window. These engines share common characteristics. They use electronic fuel injection, yet the systems are simple enough to diagnose and repair without factory software. They have engine management computers, yet those computers monitor basic parameters and use straightforward logic. They incorporate modern materials like stainless steel and corrosion-resistant alloys, yet the core architecture remains mechanically straightforward. The Honda BF115 from 1998 is a perfect example. It uses electronic fuel injection with a simple engine control unit. The ECU monitors throttle position, engine speed, water temperature, and intake air temperature. That's it. No oxygen sensors, no exhaust gas recirculation, no variable valve timing, just enough electronics to optimize fuel delivery without creating complexity that causes problems. The cooling system is purely mechanical, water pump driven off the driveshaft. Thermostat controlling flow, pressure relief preventing overpressure. Every component can be understood, tested, and replaced with basic tools. When something goes wrong, you can diagnose it by observing how the system behaves. No software required. The diesel side tells the same story. The Yanmar Forza JH4 series from the late 90s and early 2000s represents the peak of reliable marine diesel design. These engines use indirect injection, where fuel sprays into a pre-combustion chamber rather than directly into the main combustion chamber. This creates more forgiving combustion that tolerates lower quality fuel and produces less stress on components. The fuel system uses a mechanical injection pump, typically a Bosch or Zexel unit that's been proven over millions of engines. The pump is adjustable, rebuildable, and completely mechanical. When it needs service, any competent diesel mechanic can work on it. No proprietary software, no factory-only diagnostic tools, just mechanical precision that's been understood for decades. The engine management on these Yanmars is minimal. An alternator provides charging. A starting motor cranks the engine. Oil pressure sensor triggers a warning light. A temperature sensor does the same. That's the extent of the electronics. Everything else is mechanical, which means everything else is straightforward to maintain and repair. The cooling system uses a heat exchanger to separate raw water from the engine's internal coolant. The raw water pump is mechanically driven. The thermostat is a simple wax pellet design that's been used since the 1930s. The whole system can be serviced with hand tools in an afternoon. So why is this era so special? The late 90s engines sit right before several regulatory changes that fundamentally altered marine engine design. In 2006, the EPA implemented new emission standards for marine engines. These standards required significant changes to combustion systems, fuel delivery, and exhaust treatment. Manufacturers responded by adding complexity. Common rail diesel injection replaced mechanical pumps. This improved efficiency and reduced emissions, yet created systems with injection pressures exceeding 30,000 psi. At those pressures, fuel system components become precision items that require specialized tools and training to service. The high-pressure pumps themselves became wear items that need replacement or rebuilding at intervals that older mechanical pumps never required. Gasoline outboards gained oxygen sensors, catalytic converters, and sophisticated engine management systems with dozens of sensors. These systems work well when everything functions correctly. When something fails, diagnosis requires factory diagnostic software and specialized knowledge. The days of troubleshooting with a multimeter and basic understanding of ignition systems ended. Variable valve timing appeared, adding mechanical complexity to valve trains that had been essentially unchanged for decades. The systems improve power and efficiency across the RPM range, yet they introduce oil pressure requirements, solenoids, and timing components that can fail. More parts means more potential failure points. Direct injection in both gasoline and diesel engines created new maintenance requirements. Carbon buildup on intake valves became an issue requiring periodic cleaning. Injectors became more sensitive to fuel quality. High-pressure fuel pumps became wear items. The older port-injected gasoline engines and indirect injection diesels avoided these problems entirely. The serviceability difference is enormous. A late 90s Honda BF115 can be diagnosed and repaired with basic tools and knowledge. Compression test tells you about internal condition. Spark test shows ignition system function. Fuel pressure gauge confirms fuel delivery. Water flow observation checks cooling system. Everything can be tested with simple equipment and basic understanding of how engines work. A modern outboard with all the current emissions equipment requires different approaches. The engine management system needs to be interrogated with diagnostic software to read fault codes and live data. Variable valve timing adds complexity to valve train diagnosis. Direct injection means you need specialized tools to check injector function. The oxygen sensors and catalytic converters add new failure modes that didn't exist before. This matters enormously to mechanics who fix engines for a living. They understand that complexity equals cost, both in parts and in diagnostic time. They also understand that sophisticated systems work perfectly when new, yet develop issues as they age. Sensors drift, solenoids stick, software glitches appear. Meanwhile, the mechanical systems in older engines just keep working. The parts availability and cost difference is significant too. A fuel injection pump for a late 90s Yanmar costs a few $100s and can be rebuilt. A common rail high-pressure pump for a modern diesel costs thousands and often requires replacement rather than rebuilding. The older mechanical injectors cost tens of dollars each. Modern piezoelectric injectors cost hundreds. But age brings its own challenges. A 25-year-old engine is not perfect just because it's from the sweet spot era. These engines have been running for 2.5 decades. They've accumulated hours. They've been exposed to salt water, humidity, and vibration. They've been maintained to varying standards by previous owners who may or may not have known what they were doing. The key is finding examples that were maintained properly and show honest hours. A late 90s diesel with documented oil changes, cooling system service, and proper winterization will run for many more years. The same engine that was neglected, run low on oil, or operated with a failing cooling system might need extensive work to bring back to reliable condition. This is where mechanics have an advantage. They can assess an engine's condition accurately. They know what to look for. Compression numbers, oil analysis, cooling system condition, evidence of overheating or water intrusion. They can distinguish between an engine that's been used and maintained versus one that's been abused and neglected. When they find a good example from this era, they know they're getting an engine with proven reliability and straightforward serviceability. The mechanical condition can be verified, the systems can be inspected, any problems can be identified and corrected. Once sorted, these engines deliver reliable service for years to come, the specific models that mechanics choose most. The Yamaha F115 4-stroke from 1999 onward appears on mechanic-owned boats constantly. This engine uses a proven architecture with simple electronics. The powerhead is robust, the lower unit is well designed. Parts availability stays excellent because Yamaha sold thousands of these engines and continues supporting them with parts. The Honda BF75 and BF90 from 1995 get similar respect, as do the updated versions. Honda's manufacturing quality and attention to corrosion protection shows up in engines that last. The BF115 and BF130 from 1998 use simple fuel injection systems that work reliably without creating diagnostic nightmares. The mechanical components are overbuilt relative to power output, which extends service life. On the diesel side, the Yanmar 4JH3 and 4JH4 series from the late 90s and early 2000s dominate. These engines represent the peak of indirect injection reliability. They're simple enough to work on anywhere, yet sophisticated enough to run efficiently. Parts availability stays good through both Yanmar's dealer network and aftermarket suppliers. The Perkins M35 and M50 from this era also appear frequently. These are marinized versions of Perkins industrial diesels, which means they were designed for continuous operation under load. The blocks are cast iron. The injection systems are mechanical. Everything is straightforward and serviceable. The Volvo Penta MD series diesels from the late 90s get attention too, particularly for sailboat applications. These engines use indirect injection and mechanical fuel systems. The marinization is well executed with proper cooling and corrosion protection. Volvo's dealer network provides long-term parts support. The two-stroke window is narrower but interesting. The Mercury Optimax two-stroke from 1996 through the early 2000s represents advanced two-stroke technology done right. These engines use direct injection to deliver fuel precisely, which improves efficiency and reduces emissions compared to older carbureted two-strokes. The system is sophisticated enough to work well, yet simple enough to remain serviceable. Mechanics who run Optimax engines appreciate the power-to-weight advantage of two-stroke architecture combined with reliability that approaches four strokes. The engines are lighter than equivalent four strokes, which matters on transoms and for overall boat performance. The direct injection system eliminates the oil smoke and fuel waste of older two-strokes. The key with Optimax engines is proper maintenance of the injection system. The oil injection pump needs to function correctly. The fuel injectors need to stay clean. The engine management system needs to operate properly. When maintained correctly, these engines deliver reliable service. The early models from 1996 through 2000 had issues that Mercury resolved, making 2001 and later models much more dependable. The Evinrude E-Tech from the mid-2000s represents the next evolution of direct injection two-strokes. Some mechanics run these, particularly those who specialize in Evinrude service. The technology is sound, yet the brand's demise in 2020 creates long-term parts availability concerns that make older E-Techs less attractive than they were when the company still existed. What this tells us about modern engines. The fact that mechanics choose 25-year-old engines for their personal boats reveals something important about modern marine propulsion. The newest engines are not necessarily the best engines. The most sophisticated technology is not necessarily the most reliable technology. Complexity adds capability, yet it also adds failure points. Modern engines excel in many ways. They produce more power per displacement. They burn fuel more efficiently. They generate fewer emissions. They run quieter. They provide better diagnostic information through sophisticated monitoring systems. All of these advantages are real and valuable. Yet these advantages come at a cost that extends beyond the higher purchase price. The complexity requires specialized diagnostic equipment. Repairs often require factory-trained technicians. Parts costs are higher. Service intervals may be more frequent. The long-term durability remains unproven because these engines have not been in service for 25 years yet. Mechanics understand these trade-offs intimately. They see the warranty repairs on new engines. They diagnose the sensor failures and software glitches. They replace the expensive high-pressure fuel pumps and piezoelectric injectors. They order the parts that cost twice what the equivalent components cost on older engines. This daily experience informs their personal buying decisions, but context matters enormously. A mechanic running a 25-year-old engine is not making the same decision as a typical boat owner. The mechanic has the knowledge to assess condition accurately. They have the skills to perform their own maintenance and repairs. They have the tools and equipment to work on marine engines. They have access to parts at wholesale prices. Most importantly, they know which problems they can fix themselves and which ones require outside help. For a typical boat owner without mechanical background, a newer engine might make more sense despite the complexity. The warranty coverage provides protection against expensive failures. The dealer network handles service and repairs. The sophisticated diagnostics identify problems before they become catastrophic. The improved fuel efficiency saves money over time. The sweet spot era engines work best for owners who either have mechanical aptitude themselves or have established relationships with mechanics who can maintain these older designs. These engines reward owners who understand them and maintain them properly. They punish owners who neglect them or attempt repairs without proper knowledge. The market reflects this knowledge. Well-maintained engines from the late 90s and early 2000s command strong prices in the used market. A Yamaha F-115 from 2000 with documented maintenance and honest hours sells for surprisingly high percentages of what it cost new. Buyers recognize the value of proven reliability and straightforward serviceability. The same pattern appears in the diesel market. A Yanmar 4JH4 from 2002 with service records and low hours is worth significant money. Buyers, particularly those planning extended cruising or living aboard, understand that these engines will run reliably for years to come with proper maintenance. The mechanics who choose these engines for their personal boats are not being cheap or backward-looking. They're making informed decisions based on years of experience fixing every brand and model that comes through their shops. When they see patterns of reliability and patterns of failure across thousands of engines, they know which designs succeed long-term. Their choices validate what the service records show. The late 90s and early 2000s produced marine engines that hit a sweet spot of reliability, serviceability, and longevity that has not been matched since. Not because modern engineering is worse, but because regulatory requirements have forced complexity that creates new challenges. So what should you do with this information? If you're shopping for a boat or repowering, understanding this sweet spot matters. A well-maintained engine from this era, properly surveyed and verified, can be a better long-term investment than a brand new engine. The purchase price is lower. The technology is proven. The serviceability is straightforward. The part support remains excellent. The key is honest assessment. A 25-year-old engine that was maintained poorly or operated hard might need extensive work. Compression testing, oil analysis, and thorough mechanical inspection reveal true condition. A qualified marine surveyor or mechanic can assess whether a specific engine is a good candidate or a project waiting to drain your bank account. For owners who change boats frequently or prefer the latest technology, newer engines might suit better despite the complexity. The decision depends on your priorities, mechanical aptitude, and how you use your boat. So, what engine are you running, and would you choose it again? Do you prefer the simplicity of older designs or the sophistication of modern engines? Drop your thoughts in the comments. The mechanics have spoken with their wallets. Now let's hear what real boaters think. Thanks for watching.